Hello, in this video, I will show you how to run Alphafold in the HPC clusters, especially in Sweden. But the idea can extend it to other HPC resources as well. So Alphafold is a program to predict the three-dimensional structure of proteins. If you're curious about how Alphafold works and some more details, you can go to this paper in Nature, right? And have a better understanding of what Alphafold can do. So I will illustrate the workflow for a simple protein. This is 6-OSN, and I choose this one because it's a relatively small protein. And notice here that it was deposited on 2019 and released in 2020. And I will pay attention to these dates later on. So we can do the common thing, such as download the FASTA sequence and the PDB file, right? So I will download it. So I have done it already. And these structures are already in my folder here. So as you can see now, I'm working on Windows. So then I will transfer this file to a HPC system. The tool that I use to transfer the file is called WinSCP, right? So here you start by writing the host name, and in particular for this case, I will use Kebnekaise, and this is the address, and then the username and the password. And when you do this, then you can transfer the files to some specific location where you want them in your directory on the Kebnekaise machine. So I did it already, and I transferred the files. And as you can see here, I got a folder with the same name because I transferred the entire folder, right? If you're working on a different operating system, then you could use a different protocol for transferring the files. One can also use FTP, right, on Linux or on Mac. So, okay, so I have the files that I needed here. In particular, this is the FASTA sequence of the protein. And I also transferred the PDB file that was deposited on the protein data bank. So here on the HPC resource, Kebnekaise, we don't work in a similar way as in Google Colab, yes, and some of you may have started with the Google Colab and Alphafold and discovered that the models are just too big, yes, and too expensive computationally to proceed with Google Colab. So maybe you already started thinking about porting your workflow to an HPC system. And here, right, in our resource, Kebnekaise, we don't submit the job directly, right? But instead we use a queuing system, right? Where we write some script, and this script is then sent to a compute node, and everything is run on the compute node, and then we can obtain the results, yes, right, in our working directory. So how does it work? So we need to write a so-called batch script. And here I wrote one already. Right? It's called job.sh, and this is specific for a Kebnekaise machine. So here in the first line, this is the shell interpreter that we will use is bash, and this is the one supported at HPC2N. This line should be present in all your batch jobs. Then we start with the proper directives for the queuing system. And we use slurm, yes, and the lines start with this dash symbol followed by S batch. So everything that starts in this way will be interpreted as a slurm directive. So the minus capital A means the project name that you receive, yes, when you apply on Super for your account. This is the time that you will request. In particular here, this is 8 hours, 0 minutes, and 0 seconds. This is the number of cores that you will request, and in this case is 14. And here you request the type of GPUs that you need. On Kebnekaise for Alphafold, you can use only the V100s, and we select 2 GPU cards. So we need this flag on Kebnekaise -- exclusive, right? And here with the -- output, you will write the name of the output file. And if there are some errors from Alphafold or some errors in the process, then they will send you this job_o error file. So here we start by doing some cleaning in the environment with this directive. So you are strongly recommended to use this line in all your batch script, which will remove some environment modules that could be present in your batch session. Then we load the requirements for Alphafold, and these are the 2 modules listed here, the GCC and OpenMPI. And finally, we load the Alphafold module for this version 2.2.2 with the appropriate CUDA module. So here there is one environment variable that Alphafold recommends, and this is for the HHL Blitz program, right? And here we are assigning 14 CPUs, and this is the number that I wrote above for the number of cores, right? Here. So in the particular case for Alphafold, so we noticed that the structure was deposited on 2019 and this month, right? And released in 2020. And here I just wrote the resolution, but notice here that this line is just a comment, right? Only the lines that starts with dash and S batch are Slurm directives. Otherwise, they are comments. This is a comment, this is another comment, and this is another comment. And here we start the Alphafold command, and we need this dash dash fast, the path, and here we write the name of the FASTA sequence file, right? In the particular case, here I wrote the FASTA sequence, and I can open this file. And you will see that this is the FASTA sequence that I downloaded from the PDB, the protein data bank. So it has 98 amino acids, right? Then here we set the maximum date for computing for computing or for predicting or for taking the database as a training part, right? So if I write something after the structure was deposited, then it should be there, right? So it doesn't make sense to try to predict the structure in that way. So here we set the model that we will use, and Alphafold supports a monomer and also multimer. And here is the output directory. And in this case, this will be the working directory where I submit the script. So notice here that the version of Alphafold is 2.2.2. And we have in our website at HPC2N, we have some instructions for under the software level. We have some instructions for Alphafold. And here there are some description of how Alphafold works, but this is mainly for Alphafold 2.0.0. And if you are still using this version, so you will notice that there are some changes in the way that Alphafold uses the options. FASTA paths is still there, but for instance, this preset and model names is not used any longer in Alphafold 2.2.2. So you can take a look at this page also from HPC2N. So, okay, once we have this script, then we can submit the job to the queue with the sbatch command, right? And when you do this, you will get a number, right? And later on, you can check your job status with the SQ command. And here you need to write your username. This will tell you how your jobs are running, or if they are still pending, right? So they haven't started running. So the number that I got from sbatch, in my case, because I submitted the job previously, was something like this, right? And on the terminal, you can type job usage and this number here, and this will give you a link a URL. So then you can copy, I will copy this, and then I paste this link on a web browser. And if you do this, you will get some statistics of the job. So here you will see how the CPUs were used, the total number of CPUs that I requested, and also how the GPUs are being used, right? And this is a good way to monitor the performance of your job. And this is a tool that we have here at HPC2N. So, okay, so this job already finished. And if everything went well, then you could see here the folder generated by Alphafold, where the structures or the best structures are included. For instance, the rank 0, rank 1, rank 2, and so on. So if you are curious about how they look like, we can take a look at them. And now I'm using a program called a VMD for visualizing the structures. And here you can see the two structures. They are not visible in some convenient manner, but we can change here the settings. I will change the representations. And here you can see here is the ranked 0 structure, right? Notice that because I included the entire pasta sequence, then even the tail that is not modeled in the deposited structure is being modeled here. And here in blue, we have the structure that is deposited in the protein data bank. So we can align these structures, yes, because otherwise we cannot see the similarity between them. We can use the multi-sec option from VMD. And we try some structural alignment. And you can see here how they overlap. I will change again the settings, and you can see that this dark blue structure is the predicted by Alphafold, and the magenta is the one deposited at the protein data bank. So everything seems to be aligned here, right? So showing that the prediction is okay. And the difference could be here in the tail, right? So, okay. And so maybe you are curious on how to run a similar setup in a different machine. For instance, in Sweden, there is another machine called Alvis at Chalmers. And here I prepared a input file. And here you can see the main differences between the batch scripts used in Chalmers and here at HPC2N. Here is the batch script for Alvis machine, and here is the batch script for Kebnekaise. So in particular, they use a dash option, which essentially does the same as the dash T. Yes, this is for the time. Instead of the dash C as we are using here, they use the dash CPUs per task, and also they specify the total number of tasks, with each in this case is just one. And here they specify the number of GPU cards in this way, right? While we use the dash GRS. And notice here that I'm using the V capital 100, and sometimes these capital letters are very important in the batch script. Here I included the same cleaning line as I mentioned before. And the module that I use for this case is Alphafold 2.2 and FOSS 2021A with a CUDA support. So the Alphafold HH Blitz is set to 16 here. And this is because for when using two B100 cards here, one is granted with 16 cores. And this is different to Kebnekaise, where I requested 14. So in Alvis, we also need, I will close this window. In Alvis, we also need to set the database path, and this is set already in Kebnekaise, so that's why you don't need to specify the location of the databases. And the way that we run Alphafold is similar. We just write the FASTA sequence, the max template date, the model that we will use in this case is just a monomer, and the output directory, which is set to the working directory. So, and the way to work in Alvis is similar to the one in Kebnekaise. We just write sbatch, submit the script. And the one feature in Alvis is that they provide you with the URL link that I mentioned before for monitoring the job usage, right, directly. So you don't need this command job usage that we use at HPC2, and you get it automatically in Alvis, but it is in the output job, right? So, okay, I think it's everything I wanted to mention about Alphafold, and thank you.